All right, well, I wanted to have a chance to go over free response 23. This is a great example of cumulative frequency plots and being able to use them and interpret them to compare distributions, which is always important in statistics. So you'll notice that we're talking about systolic blood pressure readings here, and we have three distributions, A, B, and C. And we're being asked to write a few sentences comparing the distributions of systolic blood pressures in three countries. There are a lot of ways we can approach this. Now, first of all, I think we should know that we usually go by the acronym SOX as far as what we should cover when we're discussing distributions. I like to talk about spread. We like to talk about possible outliers or gaps, center, and shape. We all want to do this using context. So let's start out with, we can talk about the spread a bit. Now with the cumulative frequency plot, remember, you're looking for where it starts here, and then we want to talk about where it ends. Now, if we look at A, we notice that 100% of our data, when we reach 100%, we're at about 135 right here, which means we have data in distribution A from 75, well, it says, doesn't say how we, MMHG. It's always good, know the units you're looking at. So A, we're looking at a range of 75 to about 135. Because you'll notice once here it flattens out, that means we're not accumulating any data in this distribution anymore. We've reached 100% of our data. 100% is from 75 to 135. Now, if I look at B, I'll do it in a different color here. We're starting at 75, and you'll notice B keeps going. We don't really have a flat line here. It ends right around here, about 165. So we notice that we already have a greater range with B. Now, if we look at C, you're going to notice it's the same thing. It starts at the same point, starts at 75. And it ends right here at 165. So the first thing I can say within, using a sentence here is, let's see, country A, a smaller range of MMHG than countries B and C, which I'm also going to put which are equal. Notice I'm not getting specific about numbers here. When it's asking to compare, just talk about which is greater or less. I mean, you can use numbers at some point if you want to, but when you're doing comparisons, think about things like greater than, less than, equal to. All right, so I'm going to jump to the next one now, which is outliers or gaps. Now, some people might argue that you can't determine outliers or gaps from a cumulative frequency plot. However, I argue that you can approximate them. Here's why. In order to calculate outliers, you can either deal with stuff that's more than 2 standard deviations from the mean, which we don't have that information here, but we can use quartiles. If I approximate where 25 percentile is, I'm going to put a nice line here. That's going to give me the 25th percentile for each country. So right here in country A, this is going to be an approximation. I'd say this is about 80. Country B, I can say it's maybe, let's see, 5. I'm approximating here. So let's see, we went from 15, so we're going up by 3s. Maybe I'll say maybe it's about 108. And then for C here, I'm going to get about, let's say about 141. Again, I'm just approximating. But at least it gives me something to work with so I can determine what outliers might look like. I could say what are potential outliers or possible outliers. Again, I did that using quartiles because I'm looking at quartile 1, which is the 25th percentile. I can approximate that on each of these. I'm going to do the same thing for the 75th. I'm going to figure out where the 75th percentile is. I'm just going to draw a line here, and this will approximate where my 25th percentile is. And let's see, I'm looking at about, let's see. Oops. So we have erasers here. Again, I'm just approximating but it'll give me enough information that I can work with here. So I'm looking at about halfway from 90 to 105. We'll call this 97. Here we have about, let's see, 132. Yeah, I'm making just tick marks to represent threes. That's just the way I went with this. You could have gone, you can approximate any way you want. Again, we're just looking at approximations now. What's important to know that we can make approximations here. That's always a good thing. So let's see, I'm here at the 75th percentile, and I'm looking at something quite higher here. I'm looking at maybe like 160-ish. Yeah, I'll say 160. Which means I can also tie something into my range here, because I can approximate what my IQRs look like, which have the wider IQRs, which have the shorter ones. We look here, we only have an IQR here, distance between Q3 and Q1 of 17. Around here, we have an IQR of about 24. And then here we have an IQR of about 19. So I can approximate that country B has a wider IQR, has a greater IQR. Country B has a greater approximate IQR. Again, use what information you're given. I could say the least IQR, if I'm looking here, I've got somewhere between 19 and for C, 17 for A. That's pretty close. I'd probably hesitate on saying which one's greater than the other at this point, just because, as you can see, I was approximating distances here. So I could say they're approximately equal, just again, because I was approximating here. It's not a bad idea to do that, but you don't want to go too far if they're this close. So I could say the IQR for countries A and C are approximately equal. As you can see by doing this, I'm opening up a whole wide range of things that I can look into now. Now they have IQRs, I can start thinking about what outliers look like. Now remember, the formula for an outlier, when you have quartiles that you can work with, is, let's see, 1.5 times your IQR, and then you're going to add that value to Q3, subtract it from Q1. The way I like to explain it is like if I made a box plot, right? The IQR is this box. What I'm essentially doing is I'm taking this box up. Let's see if I can catch it without the tail here. Wish me luck. Cool. I'm taking this box, right? I'm going from the edge of Q3, and then I'm just going a little wider. Going a bit wider, and then anything outside over here would be considered an outlier. I'm also taking that box. I'm going to move it left. Oops. It's all right. That's why we have erasers, right? I'm also taking this box, and I can go less than Q3, which means anything down on this end would be considered a low outlier. So when people ask like where this comes from, essentially what you're doing is you're just taking your IQR, you're stretching it out a little bit, and anything a little bit greater than that stretch is going to be considered a high outlier. Anything lower from that stretch on is going to be considered a low outlier. So let's see, if I do 1.5 times, let's see, we'll start with country A, we get 17. You get about, let's see, I should be using a calculator here. I get 25 and a half. So I can take 25 and a half, subtract that from 80, and that gives me a low outlier of, I'm approximating here, 54 and a half. Add that to 97, that's 25 and a half. And let's see, I should be using a calculator for this, but I'm approximating it just so I can keep things moving. You don't have to keep watching me use a calculator. So anything on the lower end or the higher end here would give me possible outliers. So what you can do then is you can say like, okay, are there any possible outliers in this data? In this case, we determined that our range is about 75 here to about, let's see, we said that breaking point was about 135. So we do have some possible outliers. In this case, in country A, anything beyond, maybe about right. Let's see, you're looking for 122.5. Anything beyond here, so anything from about here to here would be considered a high outlier in country A. So you do have some high outliers. Do we have any low ones? No, we don't have anything less than 75. I can do the same exact thing for country B. Again, we're getting a little deep here, but that's okay, because the thing is, cumulative frequency plots give you a lot of options. You want to make sure you're exploring all those, right? So I'm going to take 1.5 again. Once again, I'm going to multiply it times my IQR. It's 24 for country B, which gives me about 36. It's an easier number for me to work with, at least. 1.5 times 24. So I can subtract 36 from quartile 1, and 36 minus 108 gives me 72. Which means anything lower than 72 would be considered a low outlier. Again, we don't have any for country B. Let's add that 36 to 132 right here, and you get 164. We barely make it to about 160. Let's see, do we quite make it to a... Oh, we make it just about to 165, but we have a little bit right here. So anything maybe in this ballpark, maybe even smaller, I would say, for my undo button here. There we go. Cool. So anything from about where 164 to 165 would be right here, those would be our high outliers. So we have some possibilities of high outliers here for country B. Now country C, we're going to do 1.5 times 19. Again, I'm not getting that brave. I'm going to do it by hand. 28.5. Cool. So if I take 28.5, subtract that from Q1, add that to Q3, that'll give me my high outliers. So the number I had again was, that's why I'm going back to my calculator here, 28.5. Okay. That's easy to add to 160. That'd be 188.5. So I definitely don't have any high outliers for country C. And then for then for the low outliers, we had 141 here for a 25th percentile. If I take 141, take away 28.5, 112.5, which would end up being, if you look here, approximate maybe about right here. Everything from here on can be considered a low outlier in this set. That says something. So we have a lot more possibilities for low outliers. So I'll point that out. So as you can see here, country C has potential low outliers because we know where they are. You can see me shading them in here. Let's see, whereas country A and country B don't. Now, as far as high outliers go, we're looking at maybe, they're definitely more substantial for country A. So I said country C here has potential low outliers. Country A has potential high outliers. I can even point out that country B has a few. Or I could even just put more. There you go. Country A has more potential high outliers than country B and C. But hopefully what you're noticing here is that I'm using what's given to me, and I'm using it to describe this distribution. That's really important. You want to be able to do that. So next, what I'm going to do is I'm going to look at the center. The center is pretty easy with these. Just look for the 50th percentile to find that median. So if I look here, my median for A is, I can approximate that. It's kind of in the, just below 90. For B, oh boy, this is pretty pretty clear here that we can easily see that country C has the highest median. And that median is probably around 160. A, I'll put has the greatest median. Yeah, I'm going to use the units too. Always use your units. MMHG, I believe it is. Yep. And country A has the least. Now, again, I apologize for my writing. You can tell I'm writing quick here. But I like to share my thought process with you. I could have easily just done this beforehand and then just explained it, but I like to show how I'm arriving at my answers. I think that's important. So now the last thing we want to talk about is shape. So in order to talk about shape, I'm going to get rid of this stuff so we can think a bit. Now, a question I get sometimes is when it comes to drawing histograms from cumulative frequency plots. People struggle with it a little bit, but the thing it gives you a lot. It can give you a really good idea of what the shape could look like, and it helps you interpret these a bit better. So let me show you what it would look like. Like if I did A, I'm going to do a pretty basic histogram. Let's see. Well, that looks awful. So I'm going to go 75 to the range of, let's see, we determined the range of this was going to be to about, trying to straighten this out. Before it straightens out, oh boy, I could probably bring this up a little bit. There we go, cool. Like maybe halfway between, I'll say 128. So I'm going from like 75. I'll go up by the same units that they do here, 75, 90, 105, 120, and I'll go to 135. And here's what I can do. I look here for where I'm going from 75 to 90. I start at 0%, and then by the time I get to 90 here, I'm at about 55% of my data here. So then I can do a very basic frequency plot here, or a histogram. I can do it based on, my histogram here can be based on percentage here, or proportion. I'll do it based on proportion. And I'm just showing you a rough one so you can get an idea of what this could look like. But since I went up about 55%, I'll do a bar here at about 55%. And boy, talk about rough. You want to make sure you're getting your intervals right at least, right? That'd be 0.75, 0.5, and 0.25. I always advocate using technology when possible, but I think this will be at least give us some perspective on how we can interpret skew and shapes of distributions. So now I'm going from 55 here at 90, and then I'm going to get to, when I get to 105, notice that I'm going to bring this over. I'm at about 80. So I'm going from 55 to about 80. That means if I do 80 minus 55, I'm going to get about 25%. So that means my next bar here is 25% of my data falls from 90 to 105. And you'll notice that it's not as steep of a climb either. That's what you're looking for, steep climbs. The steeper it is, the more data there is. The less steep it is, the less data there is. Like right here, I'm not going to get much data, I can tell you already, because it's not very steep. So I'm going from 105 to 120. I'm only going from about 80 to 90 here. So it's only about 10%. So that's going to be very shallow. And then I pretty much bottom out at this point, because then I'm going from 120 to 135, and I'm getting that maybe 10% peak again. And you notice that I have a really strong right skew. I can tell that because I have a really steep incline here, and then it gets shallower and shallower as we go. So steep incline means a lot of data. Shallower it gets, less data. So I can tell that country A is right skewed. Again, skew, people always ask me about the direction of skew. Just look to which way direction it's sloping downwards. Since it's sloping down to the right, that would be a right skew. Now, if we look at this next one here, for B, from 75 to 90, we have a very small increase. Maybe it's just under 10%. We're not getting much growth here, not accumulating data much. 90 to 105, maybe we've accumulated maybe 15%. We haven't accumulated much. Then from 105 to 120, we're getting a lot. We got a nice steep climb here, right? We're going from about 15 to about maybe 60. That's like 45% of my data there. I'm getting a lot of it right there. And then it starts to taper off again, get less steep, and then less steep, less steep. So this time I kind of have a peak towards the middle. I got a big peak right here, and then you notice on each end I've got really shallow drop-offs. So I could say country A, or country B, excuse me, is approximately normal. Notice what I'm saying approximately. I'd have to go a long way to prove that's normal. I'd have to use the empirical rule. I'm not going that far. All I know is that it peaks right in the middle, and that at the beginning right here, I don't have much, and at the end, I don't have much. So I can say approximately normal, get away with that. Ultimately, to say it's normal, you'd have to use the empirical rule. Now, last but not least, for C, let's take a look at C. Let's take a look at C's growth here. Okay. I'm already seeing very shallow growth here from 75 to about 135. We're only accumulating, let's see, 0 to, let's see, about here, 135. We're only accumulating 25% of our data, which means only 25% of it's there. Then all of a sudden from 135 to about maybe 160, we shoot up. 75% of our data is right there at the end. That would end up being a really tall bar on a histogram. We're accumulating a lot of dots, which means in this case, we'd have a left skew. Country C, let's see, is approximately, I hate to say approximately, it's not approximately skewed, it's left skewed, is left skewed. This was rough, admittedly, but I wanted to share with you my thought process. The cool thing is we're able to talk about the spread. We're able to determine the spread from this. We're able to approximate outliers and gaps. We're able to approximate the center, and we are also able to determine the shape. Using, interquartile range, we can approximate what the outliers would look like, which is great. We can approximate what a histogram would look like by looking for growth and steepness. So the cumulative frequency plots, can be very rich pieces of information to help us analyze data. Of course, we don't know exact numbers. We don't know how many, blood pressure readings this is based on. So, that's something we're robbed of. But in the process, we can really sum up data and compare it pretty easily with the cumulative frequency plot like this.